So good afternoon, everyone. Welcome to the session of Operationalizing Your Analysis with AWS IoT Analytics. Thursday afternoon, I hope you guys had a good time at reInvent. So my name is Vikas Pangal. I am the Senior Product Manager with AWS IoT Analytics and Applications. And with me, I have Dominique Fortier, who is the Senior Software Development Manager with AWS IoT Analytics. And I have Riccardo Badaloni, who is the CEO from C2RO, who's going to talk about how C2RO is using AWS IoT Analytics for their analysis workflows and how they are operationalizing their analytical workflows using AWS IoT Analytics. So let's dive into this session and let's quickly talk about what we are going to cover today. So we'll first do a level set on what AWS IoT Analytics is, and then we're going to talk about the AWS IoT Analytics platform, how devices send messages to it and all. And then we'll talk about what do we actually mean by operationalization of analysis, and what are the typical challenges in operationalizing your analysis. And then we'll dive deep into the use cases that are useful in operationalizing your analysis. And then C2RO will come on stage and we'll talk about how they're using AWS IoT Analytics to operationalize their analytical workflows with a quick demo. So let's dive into it. So what is AWS IoT Analytics? So it's a service which ingests the data from your devices. It pre-processes that data, structures it, cleans it, stores it in its own data store, and then lets you do analysis or visualization on that data. So it's a fully managed service. What essentially that means is that it removes all the undifferentiated heavy lifting that you had to do to build any analytical solution on your IoT data. So you do not have to weave together different services to ingest the data, to do some ETL on that data, and then store that high volume of data that you're getting from your devices. So everything is fully managed within a single service and within just a few click of buttons. So let's take a look at the overall platform, like how it works and how do you get the messages into the service. So let's say you want to analyze your data, which is coming from your IoT devices. So you have a couple of options there. You can send those messages directly from your devices to IoT Analytics. As you see on the right side, the components of AWS IoT Analytics, and on the left side, you have multiple sources from where you can send these messages. So using the ingestion API, you can send those messages directly from your devices to AWS IoT Analytics. Or if you're using AWS IoT Core, which has the built-in MQTT protocol or pub/sub model, if you send your messages to a particular topic, AWS IoT Analytics can listen to that topic and get the messages inside the service. For those of you who have already built some sort of analysis or analytical workflow already and have been using existing AWS services, for example, Amazon S3, to store all of your data, devices data there, you can get that data also directly into AWS IoT Analytics using the ingestion API. Or in another instance, if you're using Kinesis streaming to stream your messages, you can use the ingestion APIs to get that message into the service. So as you see here in the architecture, so the first component of the service is channel, which is basically an entry point to the service. And it basically does two things for you. So the first thing is it stores these raw messages that you are getting from your devices or the other listed sources. And the other thing is it basically sends those messages to the next component, which is the pipeline. So the pipeline sets you with the foundation to pre-process your messages. So it has a couple of inbuilt activities. And the three inbuilt activities are to filter your data. Like if you do not want to store all of your messages, if you want to just filter some of the attributes from your messages, you can use the filtering activity to filter those message attributes. The other inbuilt activity within the pipeline is the transformation. So if you want to transform your messages from one value to the other, for example, you have a bunch of devices which are spread across, across the globe, So in the Northern America region, you're getting those device values, for example, temperature values in Fahrenheit, but in Asia Pacific, if you're getting those values in Celsius, but you wanted to do an analysis in a consistent way, so you might want to transform those values into a single dimension, which would be either Celsius or Fahrenheit. So you can use this transformation activity within the pipeline. You could also do a conditional transformation in the pipeline using the built-in activities. You can set up your condition. It's very easy to set that condition using the user interface provided by the service. And then the third activity is the enrichment activity. So this basically helps you to give some context on what type of data it is and builds a holistic perspective around that data. So for example, and you can use this enrichment activity to enrich your messages from device registry, IoT device registry, or shadow. So that way you get more information about what type of message it is. And besides these three inbuilt activities, the pipeline also offers you a Lambda function, which is a very powerful tool for you to do any advanced transformation or any complex enrichment to build some contextual information. To give you an example, let's say you have some devices which are sending, and each of those devices have some sensors which are sending some messages. That could be any message. But you have your own CRM system which you have been maintaining on-premise, which has all the customer details and location details and whatnot. So you might want to just get that information for each message to see like, hey, who's this customer, what this device, who this customer using this device belongs to this guy, and what is their usage pattern. So it'll actually give you more contextual information when you do the final analysis. So you can use the Lambda function to build that contextual information. So once the pre-processing is being done in the pipeline, it sends next to the data store. So all of your processed messages are going to the data store, as you see here. And this is, again, a fully managed data store, which means the basic data lifecycle management is handled with just a few click of buttons. You can set up your own retention policy. This data store does the automatic compression of data, so that way you do not have to pay too much. As well, it also partitions your data based on time. So wherever new messages are coming, it will partition them in such a way that when you try to access them through a SQL query or any other tool, you would get a faster response time as compared to any other solution that you would simply just dumping your data into. So when your data is being stored in the processed data store, at that point, it becomes completely available for you to do an analysis. And AWS IoT Analytics gives you two types of analytical capabilities. One is very generic, which might be used by almost everybody here, is the descriptive analysis, like wanted to find out, hey, tell me what is the last 30-day active devices, or who are the active customers, what are their usage patterns. It's just a bunch of SQL queries that you can write, and you can actually schedule those queries as well, which will be running on this data stores. So the result of these queries is basically a columnar output, which you can export as well if you're using any external visualization tool, such as Tableau or Power BI or anything else. Or you can also link this result of SQL to a QuickSight, which is Amazon's visualization tool. So there's an inbuilt connector available between these. So that way, you can set up a dashboard there, and if you have weekly cadence to review your devices or something, you can schedule these queries, and every week, by the time your meeting is coming, you would have the results up and ready, and your dashboard is also updated. So that was just one case of descriptive analysis. Now, the other important analytical use case which IoT Analytics solves is the sort of advanced analysis, primarily towards predictive maintenance or prescriptive sort of analysis. So AWS IoT Analytics gives you Jupyter notebooks, and it offers you a blank notebook and some templatized notebooks as well. If you wanted to get started quickly, you can use a templatized notebook. So there are 6 templates available to you, and these templates have been pre-authored, pre-coded using a sample data. And it basically helps you to get started very easily, even if you do not have machine learning or core Python experience. It's just a few sections in the notebook template that you just have to modify based on your preferences. You can set up your own parameters, and you do not even have to bother about the analytical code or the model code per se, and everything will be handled for you within a few click of buttons. If you wanted to start with a with a complete blank slate. You can use the blank notebook and put up your own analytical code on that. So these Jupyter notebooks basically help you get started as seamlessly with your advanced analysis use case. So if you see right from the point of data ingestion in the channels, which is the first component, to the point where you get the analysis result, it could be a SQL data set or your Jupyter notebooks. Everything is being seamlessly managed within a single service. You do not even have to use any other external component to build your analytical workflow. And all of these components are connected with just a few click of buttons, and you can get started within few minutes with this. So now let's talk about what is operationalization of analysis and what do we mean by that. So our business analysts or data scientists usually run some ad hoc analysis to explore the data, to find out what is going on with their devices or what is going on with the data per se, or is there any outlier in the data that they should be alarmed and they should notify to their management or to the operations team. But what is even more important here is that when they run this ad hoc analysis and they reach to a point where they've got a model that they can simply use for their production devices, continuously run it across their devices. The important thing is, how do they programmatically automate this model that they have created to run against these devices which are running round the clock or being sporadically used by the customer. So that way, they do not have to sit in front of the system and continuously and run these models on ad hoc basis. It is basically everything programmed, and they are getting the insights continuously. So that is basically the operationalization of analysis. So it's basically a process for you to run continuous analysis on your devices which are operating continuously out in the field or being used by the customer. So that way you get the continuous insights, and you are able to build your analytical workflow, which is running continuously around the clock to give you a better product quality insights, as well as help you to improve your customer satisfaction. Now, how easy it is to operationalize. So there are a couple of challenges. Like I was saying, it is a model to run continuous analysis. So definitely we would need a continuous analysis framework, any system that would be able to take the data from the devices as and when the data comes and simply just run it and give you the insight. The other challenge is that that very system that you have to run the continuous analysis should be able to leverage or should be able to use your existing workflows. So some of our BI experts or data scientists might be using Jupyter notebooks, whereas others might be using some other external tools that could be based on MATLAB, Octave, or any other open source systems-based tools. So this continuous analysis framework should be able to pick those external tools and run on its framework. So that way, these BI guys or data scientists do not have to reinvent everything again on the Jupyter notebooks or any proprietary tools. So the other challenge is like when this message is coming from the devices continuously, or when you onboard new customers on these devices, you see new data emerging out of these devices, and that new data would lead to new patterns. That new patterns would lead you to retrain your models. You have to retrain your models so that way you can improve the accuracy of your models for your continuous analysis workflow. So these are a couple of challenges that all of your continuous analysis framework should be able to provide. The good news is AWS IoT Analytics does all of these. It simplifies everything to help you run this continuous analysis framework because it offers that framework to you. It gives you the flexibility to bring any external custom code and run on it. And it also gives you enough primitives to continuously train or periodically retrain your machine learning model for a better accuracy and prediction results. So now I'm going to invite Dominic Fortier, who is our senior software development manager, to dive deep into each of the use cases required to operationalize your analysis. So.
Thank you, Vikas.
Mm-hmm.
So I'm going to be talking about a number of use cases of continuous analysis, of operationalizing your analyses. And the first one that I'd like to talk about is the foundation, the cornerstone of that. It's how do you run continuous analysis on your IoT data? How do you get insight on a continuous basis from your IoT data? And the use case that I'm going to be talking about here makes use of all of the different elements of the system, from ingestion at scale to transformation, store in the data store, and now get to how do I realize this continuous analysis? Well, two things. First, step one, you need to extract your data out of the system with a SQL query, creating this materialized view that we call a data set. Then, you will then execute your analysis that has been authored, maybe in a Jupyter Notebooks, maybe in something else, and you will link that so that every time that your data gets extracted out of the system, then the analysis automatically will run on that. Now, you can schedule this extraction of the data on a timer anytime from once a day, once a week, every hour, every 15 minutes, or even faster than that, and say, I want to refresh the result of my insights and publish a new version of that. Great. Now, why do I call it continuous analysis with state management? Is some analyses might be independent of each other, but some other might use the results of the previous run as an input into the next one. The system that we created, AWS IoT Analytics, lets you store the results of a run of the analysis along with all of the different things, and then it lets you in the next run consume the previous result, continue the computing, and then store that state as well. So that really lets you achieve this continuous analysis at this point because you're using the previous result to continue. We also created in there a functionality which is a delta window functionality so that you can be assured that since the last execution, you will actually now analyze exactly all of the new data that has been generated, not a single bit more or not missing anything. We found by talking to our customer that this was actually a very difficult thing to achieve with pure SQL. How do I actually get exactly the amount of data that the data that came in since the last run? So we encoded that into a feature of the system that you can use to realize that. So with these delta windows of queries and then triggering a dependent analysis and saving the state and reusing the state, you're able to realize this continuous analysis. Now, this is an example here of one of our customers. This customer is doing beer membrane filtration. They have giant amount of beer being brewed. And what they want to do is they want to know at any given time what's the quality of the different batches of beer. And they want to be able to lower their cost through analysis. And they're using our system, AWS IoT Analytics, to achieve this purpose. Second, you're going to say, well, what type of analysis can I do? We found that some customers have analyses that have been written 10 years ago, 15 years ago, and maybe they were written in MATLAB, maybe they were written in a number of things, and maybe you can't touch it because it's been certified, and you say, if I move a bit, I'll have to go through certification again. So how do I use that? Or maybe you say, Jupyter Notebooks, which is a great way of going, is not really the right tool for me. So what we created here, you can bring your own analysis, wherever it was written in whatever way. If you can actually take that analysis and make it into a container, a Docker container, you can give it to the system, and the system will execute that analysis without having to know what it is. This is an example of some of our customers in the consumer space that have analysis that was running MATLAB and Octave. And they use the system to actually achieve this continuous analysis using these analyses that were written in MATLAB. Third one, great. So that was if I have existing or if I have specialized analysis. But the standard these days in the analysis world that data scientists use is a Jupyter Notebook. So what we decided to do there is make it super easy to use these Jupyter notebooks to author your analysis by offering right there the integration and the template like Vikas was talking about, but also make it very, very easy to take those notebooks and turn them into a unit that can be used in an operationalized way to produce continuous results. Prior to that, what you would have to do, your data scientist would have authored an analysis in a notebook. And every time you wanted to know your new data, he would have gone into the notebook and refreshed the analysis and given you maybe a printout of the analysis. But you want to operationalize that. You don't want to keep that data scientist in the loop. So what we created is we created a containerization integration right there in the Jupyter interface, where you can click and say, containerize my analysis. We're going to take the Jupyter notebook. We're going to take all the libraries that are needed. We're going to put the kernel in place. We're going to turn this into a container, which is effectively an analysis as a big cloud function. And we're going to let you define what the interface to that analysis is so that you can drive from the outside, as you set it up, and parameterize and send control inputs. So we're turning this Jupyter notebooks into a giant function, a giant method that our system can call, and also that extracts the output and manage the output through versioning right alongside the other artifacts. So this here is an example of one of our customers in the oil and gas industry. And that customer has giant pumps that are pumping oil out of the ocean floor. And they came to us and say, our data scientists, by having IoT devices that monitor the vibration on the pumps of the different pumps, can forecast failures on these pumps and schedule preventive maintenance. This is a great thing. Their data scientists had that running in their laptop. They say, now we want to operationalize that. But our software department is telling us it's going to take them 6 months to integrate that notebook into something. Can you help us? So that's where we brought them this technology. Say, absolutely. You have the analysis in a Jupyter notebook right now. Use what we built, and within a few days or a week, you'll be up and running, and you'll have continuous result and predictive maintenance being run on your pumps. Another use case is these Jupyter notebooks are very powerful. There's a lot of great charts in there of your analysis. As our partner here will demo a little bit later, you'll see great charts of visualizing your analysis, but they are locked in those notebooks. If you want to open the notebooks every time and go see it, that's great. But if you want to integrate that into your workflow, integrate that into your solutions, your apps, or even just browse and see what are the analyses that ran and what were the results at a glance, the fact that they're locked in the notebooks was a little bit of a problem for our customers. So we said, OK, let's solve that problem for our customers. Let's take those charts that are in the notebooks, that are being refreshed every time the notebook runs in that container, and let's just extract them out and store in an HTML file right alongside the result of the analysis all of the charts that were produced. Now, our console also displays those charts for you automatically, so you can at a glance know what it was. But more importantly, they are available for your solution, your application, to consume alongside with the result of the analysis. So you have really, really powerful visualizations right there. This is an example of what I'm talking about here. On the left, you can see this is the chart that was in the notebook. The value was locked in there. You had to open that notebook to go see it. On the right, we're showing it how we've taken that chart out of the notebook, and we're displaying right there in the console. But that shouldn't limit you. The console is, we've done it. You can do it. You can take that same chart now. It's in HTML. Put it in your app. Put it in your solution. That really changes the nature of the result of your analysis now speaks for itself. And finally, the last use case I wanted to touch a little is this notion of training or retraining ML models. These notebooks with that integration on your data is really a powerful place to go train your ML models through the notebooks. But if you want to operationalize that and say, let's retrain this ML model on a schedule every week, every month, when there's new data, then that really becomes an operationalized training where the result of that training, the result of this ML, can then be consumed by another analysis, and it refreshes itself on the schedule that you decide. So this is basically a little bit of a map of how you would do that. The devices would be connected, and then you would have a training data set that would maybe refresh every week, and then that would lead to being used in your analysis. But I'm not going to speak much more than that. What I'm going to do instead is I'm going to let our guest here talk about how they've used IoT analytics to realize those use cases.
Thank you, Dominic. Okay, good afternoon. Very proud to be here. Thank you for having us. So at C2RO, we're doing something similar but different. Our IoT devices are actually, very highly vision-based, and a lot of the data that we're concerned about is actually what the device itself is seeing, and not so much about what the device is experiencing. So it's more about actually getting the insights around the data that's being collected by the sensor, as opposed to the state of the sensor. But nonetheless, I think it shows the versatility of the platform, and how, with an open mind, you can essentially take advantage of all of the endless data that we're collecting now more and more, in this day and age. So we're focused very much on what we call the here and now. And actually, there's always a social context to everything, including in this room specifically. And so it's all about in-person, real-world insights, and then a meaningful interaction in that moment. And so there's two aspects to that. One of them is the machine vision side, and then there's the real-time interaction piece of it. And so it's very important for us to be able, in our systems, to collect very concise machine vision data, and then quickly use our platform to transform that, usually with a partner or a use case, which ends up being one of our customers, transform that into a back communication to the person that we're trying to communicate with in that social circumstance. So this is an extension of what started with the online and mobile revolutions. And so companies like Amazon very clearly were using the online internet platform to at first offer services and then monetize the data that they were collecting and the behaviors that they were learning about through the services that they were offering, usually for free. And of course, as the mobile revolution started, many of those companies started to think very hard and invest very aggressively in finding ways to extend that behavior capturing and behavior monetization on the mobile platforms. So the last piece of that puzzle is connecting the online and the mobile with the in-person. And in a very simple example, many stores or many businesses know a lot about you through your online behavior. They know a lot about you through your mobile behavior, even where you physically are standing. But they actually know very little about what you're seeing, what you're doing, or what you're feeling in that moment, and can't communicate with you necessarily in real time. And so the last kind of frontier in terms of completing the digital interaction revolution is what we call the here and now. And obviously, with the AWS tools that we're using, we're taking a big step forward in mining the data and learning the insights that we need to optimize the communication. So it's really all about insights that lead to persuasion. And the persuasion piece is what ends up becoming the part that we monetize. So unlike a predictive failure scenario where you want to essentially intercept a failing machine before it can cause you a downtime, in our case, we're more interested in learning and finding the trends and the patterns that are in the data, in the analysis, and then essentially use that to optimize the points of communication so that we can have the maximum impact on moving the dial around customer interaction and customer perception. And so, of course, every social circumstance that you look at has information in there. And visual is much more powerful than just beacons and geolocation because, as the saying goes, a picture is worth 1,000 words. In this case, we feel a picture is worth 1,000 insights, and it turns out to be true. So, how does IoT fit into this? Well, historically, what we call legacy technology really centers around machine vision. And of course, vision means cameras. And cameras historically, were very, tied to video streaming, right? And so, as you take even this video, there's a lot of information, but, I'm taking a small piece of the image, Dominic, Vikas taking a small piece of the image, and there's a lot of waste around. So, trying to find a way to communicate the important information that's in the image using the least amount of bandwidth, but without losing the vital information that's there is an issue that needs to be solved. Wired communication, is also a problem. You don't want to be restricted in how you're essentially being able to view things. And the traditional surveillance approach where it's kind of like you want to go after the fact and kind of see what happened, that's typically the approach you take when you're setting up, surveillance systems. You kind of record everything, you go back, and now you can kind of see after the fact what happened. It's not really an approach or architecture that lends itself to really digging in, understanding what's going on in the social context, and then taking a real-time action that can change what's happening in that moment. So what we've built is a cloud-based global AI messaging system that, there's a piece of technology that goes in the device, it's connected to our cloud, and it has a tremendous impact on the ability for us to scale vision-based AI systems, not just in specific regions, but globally. And so what that means is now these devices are connected with a very high performance, very low bandwidth, a very versatile messaging system that allows you to take any device and convert it now into a machine vision powerhouse in terms of the data and insights that it's generating. And our cloud universally allows you to collect all this information, regardless of geography, using all standard networking communication, public Wi-Fi or cellular or even LAN. And you can start defining, the actions and the things that you want to recognize and the actions that you want to take when you recognize those things. So we call our platform Engage. And what it does is it allows you to take this vision recognition system that allows you to define real-time actions and bolt it on to your business intelligence software. And so in the case of a retail environment, for example, or hospitality would be a CRM, where you keep all of the relevant information about your customers. And so that allows you to not only learn endless information about specific instances and customers that is essentially added to the online and mobile experiences that they're going through every day with your products, but it also allows you now a new communication channel, a new medium that you can use for everyday touch points with your customers. And of course, the very important piece of it and where the AWS system fits into it, centers around the data analysis and the prediction of when is it the right time and what is the right way to communicate with your customers in such a way that you have an impact and can persuade them. So I'll talk a little bit about the mechanics behind the integration and then the specific use case that we used to showcase how we can use the tool specifically. So on what you call your left, you have our system. And our system is essentially two pieces. The first piece is how everything connects in a two-way, very low latency highway, right, of information between the devices that are connected and our processing engines. And there's what we call the AI application layer that allows us to put, endless combinations of AI pipelines and neural networks that are all essentially elastically being applied to the images that are coming in real time. And then there's an action piece of it that can define specific actions that are taking based on certain recognition triggers. And then the second piece is where all of the data is stored. And that's the part that hooks in to the AWS platforms. And so obviously when we're looking at the dashboard, and that's the part that the customer or us, if we're doing a data service for a customer, where the data is analyzed and where the insights essentially are buried, are going to and coming from the AWS IoT Analytics platform. And so I'm not going to spend too much on the mechanics, because actually it's very similar to what Dominic and Vikas had already described. But in general, there are three important things. So the first is, how does the data get from our systems, which are all cloud-based, our systems into the data stores that now can be essentially processed by the containers that are set up later. And so it's all JSON data format. There are Lambda functions that we create, and then that data is essentially transformed and lands in a data store. So that data store, when we have customers there, that's information and insights about our customers' customers. And that's the data that we want to mine, and that's the data that after we've mined it, can generate trends that we want to visualize and use to essentially go drive the actions that are taken. There are two relevant containers. The first is the one very similar to what Dominic mentioned, which is it's essentially the training container. And this is where we keep refreshing and keep retraining the machine learning models with new data that's continuously coming in. And because it's specific to a circumstance and it's specific to a customer, you want to do this. As we all know, the models themselves are only as good as the resolution of data that you put in. So as much as the quality is and the quantity that you put in, that's how much you're going to be able to get out. And so we really want to be able to push the data in with the most resolution we can, because when you're talking about real-time interaction, it's not about the day, it's about the moment in the day when that person is taking that action or is in a certain circumstance where you want to be able to go communicate with them. And so, getting to the point where there's a very high resolution of input data is extremely important, and actually the platform allows us to do that and allows us to retrain the model fairly frequently, which is important for us. The second piece of it is, of course, the important part, which is the net result, which is the prediction. So here, we are trying ultimately to predict eventually many different things. And as we learn more about the information we're getting, we start trying to predict many different things. And actually, the way we would use this is that these predictions are essentially sent into a second system that are inside the C2RO side. And then, the people that are communicating the insights and using the insights essentially are using the outputs of those predictions to now, essentially define when they need to take certain action. So the prediction containers are totally separate. They run regularly and are scheduled. And then they generate these raw visual outputs that are today at least interpreted by our, kind of retail experts. And then those retail experts actually can tell by the way the graphs look and the way they come out, which part of the graph we need to focus on. And that's interesting because it means that, there's an event concept that's coming out that you guys just announced, that's the type of tool actually that now we're currently internally developing that's actually still very manually oriented that we would love to automate. Unfortunately, there's a very important interpretation step in between that you can't lose sight of. And so we still have to manually interpret some of it before we end up automating it on the other side, but it's certainly getting there. Okay, so just kind of switching back now to exactly what we're trying to do. The real-life use case where we're applying this today is, one of our customers is essentially operating a retail environment, and within that retail environment, they have a hospitality offering. And that hospitality offering is catering to their most important customers. And so think of it as a daycare within a mall. And so, of course, anytime families are starting to build their lives around their children, schedule, regularity, routine becomes a very important part of your life. I have 2 daughters, and I can say that there are certain times of the week where things are very regular and scheduled, and then there are other times of the week where it tends to be a bit more ad hoc. But having looked back, you realize that it's not true. There are regular routines that pop up regularly throughout the week, especially when children enter your lives. And so here we have a circumstance where, because the daycare piece of it is in a retail environment, there's a very strong drive now to actually start trying to communicate different types of promotions, different types of services that center around the whole environment to those families at the right time and in the right context. And that communication is primarily through mobile devices. And like we all know, sometimes we're paying attention to what's coming in on the phone, and sometimes we're not, right? When we're driving in the car, it's not a good time to get a promotion because you shouldn't be looking at your phone. When you're just about to drop off your child and you got to rush to work, it's not a good time to get your mind into a mode of wanting to buy something, because that's not where your head is. Your head is, I got to get to work, I'm late. So you start to realize that just knowing where a person's going to be is not enough. You need the context of the circumstance behind the person being there. And are they now open to being persuaded? Are they open to being communicated with? And so that's the problem that we're solving. And actually, it's been very powerful because it's really centering around understanding the behavior and then actually communicating with them when they're open to it. And so it turns out that it leads to a lot less frustration. And when they learn things that they're really interested in, it ends up giving everybody what they want. The retail environment sees an uplift in sales and promotion success to those specific people, and those specific people are happy to participate because they're not being drowned by emails and SMS communication that is coming in at a time where either they don't want it or they're not interested. So it's actually a very simple way of understanding how effective some of these new communication protocols are. So we'll demonstrate, kind of moving back to technical, how we implemented this. So we have a little video. So we have roughly a 1-year database of customer behavior. There's Lambda functions that are used to essentially create the data stores. And now we can create the containers through the notebooks. So we have the model retraining itself on a weekly basis. And we use that to output predictions about when certain customers are going to be in the retail space, and which times are they going to be more susceptible to marketing communication. Okay, so the spikes represent the volume of people showing up at the specific site. So I went a little quick, so I've got still snapshots, but I want to actually show you how the visualization works. So this is the visualization dashboard that Dominic was referring to before. So as they mentioned, this is basically, I think this is outside the notebook, right, when it's executed, or is it inside?
The execution of the notebook generates those charts. Then the system takes the charts out of the notebooks and saves them alongside the result of the analysis.
Okay. Okay, so we're doing some of the visualization, within the AWS infrastructure, and then of course, as I mentioned, we've got a separate one also. So going back to the data and the insights, so what you can see here, and by the way, we didn't use the exact data that we were using, we just massaged it a little bit, just because of contractual issues, but this is very similar to what you'd actually find in that environment. So what you see is that on any given day, you've got a concentration of arrivals at the daycare. Around noon, some people come back. And then in the evening, depending on the day of the week, they come back and they pick up their kids. Okay, and this cycle on Monday, Tuesday, and Wednesday is actually fairly similar. In this particular geography, it turns out that Thursday and Friday are separate types of days, and Saturday and Sunday are separate type of work schedules. And so it turns out Monday, Tuesday, Wednesday are kind of similar, but kind of the same. And then Thursday, Friday, everything shifts later in the night because people are working later. And then Saturday and Sunday, it's a completely different behavior. If we look at a single day, the breakdown for November 26th, you can see exactly what I'm talking about in terms of the hours. And the interesting one is at noon. When they're showing up in the morning, of course, you can see everybody's there, but they're not there for very long, right? You can tell that the time that they're showing up is pretty concentrated. And they're not open to being marketed to because they have to go. They're going somewhere else. They're rarely staying in the mall. At lunch, they're coming back and they're spending time in the mall. And at night, sometimes they spend time in the mall. So actually, if you want to communicate with them, those are decent times to communicate with them, not in the morning. And then when we look at Saturday, Sunday, and Monday, we can see that on Saturday, not many of them are coming back, but some of them are coming back to the mall. Now, obviously, they're not working. They're there to shop. Great time to talk to those people. Sunday, a few more of them are back. And then Monday, we're back to the grind. So you can start seeing a just very simple insight, right, where we can see individuals, when they're coming back, when are they open to communication and when are they not? Now, these spikes need to be interpreted, but these trends are very clear. And so by having a regression, something that can be scheduled, where these models are continuously updated, we can take into account now holidays, we can take into account pet days for the kids, we can take into account all these things. And so having a regression model that becomes very granular, the more data we have, the more we can get very precise about when we can target and communicate with the people. And so this isn't really about a device failing or vibrations. It's more about trying to predict the behavior of certain people, and we're learning that families have routines and they have needs. And so if we can combine the knowledge about the routines and the knowledge of the needs, we can effectively communicate with them. And that's what our platform is providing. So thank you. Turn it back to Vikas.
Mm-hmm. Thank you, Ricardo. Thank you so much for running us through your use case, Ricardo. Actually, I hope it gives enough information to our viewers to understand how to build analytical workflows and how easy it is with just a few click of buttons to set up an analysis and embedded visualization on a single service and on a single console. So what I'm going to do is I'm going to just run you through the quick value of what we have discussed so far and what are the key takeaways from this discussion and what is the capability of this service. So we've been talking about running the continuous analysis. So that's one of those key takeaway here is like AWS IoT Analytics can operationalize your workflow now, given that you can visualize your workflow, you can visualize your analysis right from the point of getting the data from the devices to the final stage of getting the insights embedded on the dashboard. So everything is being handled and managed in a way that it will run continuously. The second thing was the machine learning models. So in the example that Ricardo was talking about, there were some logistic regression, some model being used. So we used the Jupyter notebooks templates, and then we just tweaked them and came up with these models. So that gives you an easy platform to get started with, especially when we talk about machine learning models. And the third one is the data preparation, which is in the pipeline. It gives you enough primitives to play with your data, to do some data cleansing or give it an appropriate structure on which you can actually run your analysis. And then no matter what component we talk about within AWS IoT Analytics, whether it is channel or whether it is data store, everything scales with your load. So as and when you have more number of customers onboarded, or you have more number of devices being connected in your overall size of fleet, or the overall number of messages being increased, the service is gonna consume all those messages. It's not gonna drop those packets. So it basically scales as and when your fleet increases or fleet scales, or as and when your number of customers increase. And then the data store, which is fully optimized for time, so that way it partitions your messages based on time on every day to give you faster analysis. So using this faster analysis, you can schedule your SQL queries right from 15 minutes or even lesser to whatever optimal frequency that you need. So this is all about the key takeaways that I wanted to highlight. And then in the end, I just wanted to summarize the complete end-to-end journey. So AWS IoT Analytics, it's a fully managed service. As you see, it does everything. It takes the data, it pre-processes it, stores it, gives you the storage for both the raw data as well as your processed data, so that you have enough knobs to play around with your raw data also in future. And it gives you enough analytical tools. You can run SQL queries, you can run Jupyter notebooks, or as we talked about, bringing your custom analysis. You can bring any custom sort of analysis container and run on the service, rather than spending, again, a bunch of time going back to whiteboard and rewrite everything on Jupyter notebooks or the pre-built tools. So giving you enough flexibility to run anything on the service and schedule the execution of that based on your preferred schedule or preferred windows. And in the end, it gives you the embedded visualization and give you enough primitives to export your data that you run your SQL queries on, and so that you can build your in-house dashboards, or you can use existing AWS services like QuickSight or our embedded visualization to create fully end-to-end visualization workflow. So this is all about AWS IoT Analytics in a nutshell. And I would encourage you to just go to aws.amazon.com IoT Analytics product preview page, and you can just sign up for the service and just play with the service, and you will discover that how easy it is with a few click of buttons to set up your end-to-end analytical workflow within few minutes to hours. And so with that, I would like to thank you for all of you to joining our session. I hope that this was able to give you enough information to simplify your workflow on AWS IoT Analytics. And if you have any other question, Ricardo, Dominic, and I will be available off stage to answer any of your questions that you have. With that, thank you so much, and have a great day. Yep.